All right, welcome to Class 3 of Science and Prophecy in the Bible. Today we're going to be talking about cosmology. This is really just the science of the origin and development of the universe. The main points for the class, the universe tells us it was designed by a creator. And it also seems like it's finely tuned for life, the so-called anthropic principle. We'll look at that a little bit later, but definitely seems very tuned for life. There's much evidence for a young Earth, meaning thousands of years for the universe and not billions, as is commonly talked about. And even our own solar system defies evolution as well as deep space objects and galaxies and things like that. No matter how far you look back, it all looks young. So we'll talk about that during this class. Before we get right into some of that, there's some really neat scriptures that kind of give a hint of supernatural confirmation about the universe. Um, in Psalm 19, it says, "The heavens declare the glory of God, and the firmament showeth his handiwork. In them he hath set up a tabernacle for the sun, which is a bridegroom coming out of his chamber, and rejoiceth as a strong man to run a race. His going forth is from the ends of the heaven, and his circuit to the ends of it, and there is nothing hidden from the heat thereof." And that word circuit there in the Hebrew means coming around or turning. And that's kind of an interesting phrase that's used here. Of course, the Psalms, most of them written by David, around 1000 BC, so many thousands of years ago. And yet it gives a hint of kind of modern day understanding of how the sun really moves in the sky. There's a concept called an analemma in astronomy, and it's just a diagram that shows the position of the sun in the sky as seen from a fixed location on Earth at the same time every day throughout the course of a year. So we'll start in like the very 1st of January, and every day we'll take a snapshot of the sun at a certain time at near sunset, and then create a movie out of it. And that's what this analemma is. And let's just look at an example of that. Yeah, I didn't create this movie, but it's a neat understanding of how the sun moves across the sky during over the course of a year. So you can see it starts in January, early January, around 4:40 in the afternoon. And then 24 hours later, there's another snapshot, and then another snapshot the next day, and so on. And let's just see how the sun moves in the sky across the course of a year. And then, of course, it comes back to the same place at the beginning of the next new year. So you can see it makes this ribbon. Actually looks like an infinity symbol, as was pointed out to me. Kind of neat. But that's coming around or turning. That's definitely seen in this animation of the real sun's pattern across the sky over the year. So, and there's a number of these kind of verses throughout Scripture that gives a hint of some kind of supernatural understanding of the sky and of the universe. Here's another one. This is in Job. Job's, of course, one of the oldest books of the Bible, probably the oldest, probably 4,000 years ago that it was written. And it says in Job 38, "Canst thou bind the sweet influences of the Pleiades or loose the bands of Orion?" And of course, the Orion and Pleiades uh, constellations are there. And actually, if you saw the planetary alignment earlier this week, the Pleiades was kind of the top part of that alignment, and then the Orion constellation was kind of the bottom part, and the planetary alignment kind of went through in between those two constellations. Um, but it's interesting that it's talking about binding and loosing the bands. Why would it talk about that? And why would these two particular constellations be called out in Scripture? Well, it turns out that these are the only visible constellations with direct gravitational bondage. That is, the stars are bound gravitationally to stay in place the way they are. And so, why did the writer of Job, how would he have known anything about that? Of course, he wouldn't have, not naturally anyway. But he used those particular constellations. And there's, of course, many others that he could have, but he didn't. It says there seems to be a hint of supernatural understanding of this gravitational bond between these two constellations. Psalm 19, this is one of my favorite verses. It says, "The heavens declare the glory of God, and the skies proclaim the work of his hands. Day after day they pour forth speech, night after night they display knowledge." And, I've talked about this before, but when we first moved into our sanctuary, before it was completely constructed, um, before they put the final sheetrock on the back walls and stuff, the Pastor John allowed us to go in and write scriptures on the walls before they covered it up with the sheetrock. And this was actually the verse that I wrote there on the back part of the stage of our sanctuary, Psalm 19. So, what speech and knowledge are the heavens telling us? It's pretty amazing. If you've seen the Star of Bethlehem presentation that I've done, and of course, that was definitely God speaking to us there. But just in general, what speech is he telling us? What is that supposed to be communicating to us? And it tells us that he was designed by a creator, for sure. Matter of fact, Romans 1:20 says, "For since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made, so that people are without excuse." So why are we without excuse? Because God has made it so obvious from creation that he exists and that he allows us no excuse not to believe. And it doesn't matter whether it's cosmology or biology or geology or whatever science that you want to look at. There is definitely a hint of a designer of there, and really more than just a hint. It's unequivocal evidence that there's definitely a designer of our universe. And just as an example, within our own close by solar system, how is it possible that a solar eclipse can even occur? We just had one of those just this past April, and if you were able to see that, that's almost a spiritual event to see these kind of things. But it's the chances of the moon being exactly just the right distance away from the Earth and the Sun, and the angular size of both of those objects to fit on top of each other and produce a total solar eclipse. I mean, what are the odds of that happening? I mean, that's just astronomical odds. So, what is a solar eclipse? Well, of course, you have the sun, the moon, and the Earth. And an eclipse is just when the moon gets in between the sun and the earth and produces a shadow on the earth. And if you're inside that shadow, you're going to see part of the sun, if not all of the sun, blocked by the moon. And of course, there's different types of eclipses. There's partial eclipses where the moon doesn't totally cover the sun. There's also called annular eclipses. And this is due to the fact that the moon's not in a perfect circular orbit, so it may be closer to the earth or further away. And if it's closer to the Earth, then it's not going to cover up quite the amount of the sun for a total eclipse. And so you have kind of a ring of light around the sun. But then a total solar eclipse matches almost perfectly to where the almost none of the sun is left to be seen except for maybe the corona, very outer atmosphere of the sun. And you can take the what we know about the size and the distances of the sun and the moon from the Earth, and you can calculate what that angular size is. And it's kind of interesting for the sun, it's 93 million miles away with a radius of 432,000 miles. So that gives an angular size of 0.5323 degrees. And then the moon is about 239,000 miles away. Of course, it varies, but that's on average. And we know it's about 1,080 miles in radius. So that gives an angular size of 0.5178 degrees. So there's less than a 3-degree difference in angular size. And what are the odds of that happening? And matter of fact, it's actually beneficial that it's slightly smaller because it allows us to see part of that edge of the sun, solar flares and some of the corona or atmosphere or surrounding the sun. It allows us to see some of those things and study that from our viewpoint. Matter of fact, this eclipse, like I referenced earlier, that happened on April 8th of this past year. I didn't take this picture, but I had my telescope with me and saw this very image, and I could see solar flares poking out around the side of where the sun and the moon were intersecting once it was a total eclipse. And so I would have never have seen that solar flare with my naked eye like that unless there was a total solar eclipse. I was, however, take this picture where it was in the process of becoming a solar or total eclipse, and the moon was going across the sun at the time. And basically, what you can do is take a flat white sheet of paper and hold it above the viewfinder of your telescope and let the image reflect back on the paper, and you can see that happening. And you can actually do that a little bit just by poking a hole in a sheet of paper and letting the image project down onto another white piece of paper. You don't even need a telescope to see some of that. But if you notice, I don't know if you can see it, but there's actually two black dots there on the sun. Those were sunspots that I could see. So even with just rudimentary tools like a pretty relatively cheap telescope and all that sort of thing, you're able to gain a lot of information about the sun and even the moon and how it actually works as far as a total solar eclipse. So interesting that God has made this, and the chances of this happening by accident are just astronomical. One other point to make, God's timeline is opposite of man's. When we look at the creation week, we see that the sun and the moon and the stars, those are all created on the fourth day. But of course, from evolutionary theory, we'll talk about this, something called the nebular hypothesis, where basically, the Big Bang happened, and then all these gas clouds coalesced into some spinning type mass, and eventually they coalesced even further and spun out stars and planets and things like that. Um, and of course, evolution would say that the sun and the moon happened first, and then these other things. Of course, what god were the Hebrews most likely influenced by during their time in Egypt? There's been a lot of worship over the years of the sun and the moon. And of course, pretty much everybody's probably heard of the sun god Ra. And so the Hebrews were probably very influenced by their worship of the sun. But then what did Job say about moon and sun worship? We can read that in Job 31. It says, if I had regarded the sun in its radiance or the moon moving in splendor, so that my heart was secretly enticed and my hand offered them a kiss of homage, then these also would be sins to be judged, for I would have been unfaithful to God on high. So God, in no uncertain terms, is saying that sun and moon worship is not good. Um, we'll talk about Abraham a little bit more when we get into the prophecy side, but of course, Abraham came from the Ur of the Chaldees, and moon worship was the predominant religion of at that point in time at that location. So Abraham was most likely called out of this type of pagan worship. We talked a little bit about the anthropic principle, and this is just the observation that the universe seems finely tuned for life and exploration. Of course, one of the greatest discoveries of the 20th centuries was that the universe had a beginning. And of course, it's also been discovered that it's winding down through so-called heat death, meaning that the temperature of the universe will eventually just dissipate across the universe and be uniform, and no longer life will be able to exist. Of course, their secular theories are talking about billions of years in the future, um, but still, that's the trend that they're seeing. But scientists are seeing more and more of these finely tuned parameters within the physical laws and the so-called intelligent design theory, that maybe they don't believe that the God of the Bible created the universe, but they somehow want to say that there is some creator because it's just so too finely tuned for there not to be. And it's interesting that where we are placed in our Milky Way galaxy, you can see in the picture here, of course, the spiral arms of our galaxy are there, but we're actually in between the spiral arms. And that's a very number one, safer place to be in the galaxy because it keeps you away from some of the uh, star creation and destruction that goes on and cosmic radiation that might be there. But it also allows us to see the universe. If we were inside one of these spiral arms, most likely we would not be able to see out into the cosmos near as well as we can. It would be a very cloudy, um, instrument-wise way to try to view the universe and not be able to see near as well. And also, a very interesting thing about galaxies in our particular galaxy is they've been able to measure the angular velocity of the inner rings versus the outer rings. And normally you would think that it's similar to like water going down a drain where the water at the very edge of the drain is going faster than the water at the very outside of the drain. But that's not the case. For some reason, the spiral arms, the velocities are very similar, and no one understands how that can be. They speculate that possibly this dark matter or dark energy is influencing things, but it almost seems like the galaxy is rotating in almost like a rigid disk. And you can kind of see that on this plot here. The velocities of the spiral arm motion is fairly constant across the distance from the center of the galaxy. And you don't see that with planetary motion. The planet Mercury is its orbit is 10 times faster than Pluto. And you can see that as the distance goes out, the motion or the velocity goes slower. But for some reason, galaxies are not that way. Very interesting, and no one understands it. A relatively recent word appeared in cosmological literature called a multiverse. And this is the concept where there could be infinite number of universes for our universe, and we're just happy or happens to be lucky enough for us to be in the right universe that's been tuned for human life. In 1996, it was discovered that the universe is not only expanding, it's accelerating, the so-called cosmological constant. This constant appears so finely tuned that any larger value would prohibit the formation of stars. And of course, there's a bunch of theories that try to compensate for this, and some think superstring theory will help explain things. But the equations permit 10 to the 500th power different sets of initial conditions. Most of them are life prohibiting. So this multiverse concept is just the secular world's attempt to try to say, well, yeah, the universe we live in might be finely tuned, but there's an infinite number or near an infinite number of universes that are out there that don't have life finely tuned, and we just happen to be in the one that is. And so they're out to try to prove this multiverse theory. But the bottom line is that either a designer tuned the universe that we live in, or that our universe is formed just by some luck and out of untold alternate universes from random chance. I really like this. One of my favorite verses here in Isaiah 45. Um, it's really confirms really to me the reason for this class, and why we should be interested in these topics. And let's just see what's said here. It says, "Woe unto him that striveth with his maker," and that word "striveth" in the Hebrew there means to argue or quarrel. So we're not supposed to argue with Father God. It says, "Let the potsherd strive with the potsherds of the earth. Shall the clay say to him that fashioneth, What maketh thou? Or thy work, he that hath no hands? Woe unto him that saith unto his father, What begattest thou? Or to the woman, What hast thou brought forth? Thus saith the Lord, the Holy One of Israel, and his Maker, Ask me of things to come concerning my sons, and concerning the work of my hands command ye me." So it's very interesting that he's talking about ask God himself of things to come, talking about prophecy, and concerning the work of my hands, which is creation. So he's really commanding us to ask him about prophecy and creation. We can read in verse 18 a little further. It says, "For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it, and he created it not in vain. He formed it to be inhabited. I am the Lord, and there is none else." So God has instated in no uncertain terms that he is the creator, and he formed the earth with the purpose of it being inhabited by man. God tells us to ask him of things to come, that is prophecy, and about his creation. That's the very purpose of this class. Again, talking about these finely tuned parts of the universe. Um, and there's dozens of these parameters. If Earth were 5% closer to the sun, water would boil. If it was 1% further away, water would freeze. Too much, then a runaway greenhouse effect would happen for atmosphere, or not enough atmosphere. Cosmic radiation would destroy life. Earth's reflectivity, too much and the Earth would freeze. Too little, you'd have again a runaway greenhouse effect. Even the color of the sun, if it were redder or bluer, photosynthesis would be impeded, and our green plants would not be able to survive. And just focusing in on kind of three of these anthropic principles, which are devastating if they weren't true. for us and on this entire universe. The proton's mass. The mass of a proton has been finally chosen to provide stability and that of the entire universe. If a proton's mass were 0.2% heavier, it would become unstable and decay to other quantum particles and thus destroy every hydrogen atom in the universe. And of course, hydrogen, comprises of water. Stars have hydrogen as their energy source. The human body, we're mostly water, so we have a lot of hydrogen in us. We would all just self-destruct if it were just 0.2% heavier. Not a lot of margin for error there. What about the gravitational force? So you can see that equation there. The G is the gravitational constant, and M1 is for one mass, and M2 is the second mass, where R is the distance between the two masses. And of course, it's squared, this inverse square law that you see a lot in nature. And that square, that 2 in the equation is very exact, and it's at least to the fifth decimal place. Science calls this, or Science News magazine calls this a little too neat. An increase in the exponent would cause orbits to decay, and we wouldn't even have any kind of planetary motion or anything like that. So very much tuned with the gravitational force, which we see all across the universe. Another one is the strength of an electrical charge. This is the measure of an attraction or repulsion of charged particles. And we see the same inverse square from the distance of the particles law there too. And that 2 has to be accurate to 16 decimal places, or the electrical forces would break down, bringing destruction to the universe. So it all sounds very dramatic, but it's absolutely true. If these things weren't tuned to these very fine-tuned aspects and decimal places, the universe would not exist. So these physical laws are all too neat, to coin the phrase, to have happened by chance. These are God's laws that we see mathematically. Max Planck, he lived from 1858 to 1947. He was a Nobel Prize winner and founder of modern physics. We talked, I think, last class about Planck time and Planck length. Those all were named after Max Planck. And he had this quote here that says, according to everything taught by the exact sciences about the immense realm of nature, a certain order prevails, one independent of the human mind. This order can be formulated in terms of purposeful activity. There is evidence of an intelligent order of the universe to which both man and nature are subservient. I've often said that scientists should be the biggest Christians on the planet. If you're in the science field, you more than anybody else have seen the very nature of God, and should realize that there's no way that a lot of this happened by just natural chance and natural circumstances. And unfortunately, or fortunately, back in the past, you had Sir Isaac Newton, you had Johannes Kepler, and Max Planck. I mean, a lot of these great scientists that gave us great gains in our understanding of science, they were Christians, and they believed that God created the universe and sought His wisdom in their research and in their science. But unfortunately, today it's all become so secularized, and much of the science of today is nowhere near what God would have it to be. And even Charles Darwin, 1809 to 1882, we talked a lot about him last time. Of course, the father of evolutionary theory, and he had a lot of doubts even in his own theories. He wrote a letter to his friend William Graham. It was less than a year before his own death, and expressed horrid doubt whether his own mind could be trusted if it had developed from the lower animals. So here we have the very father of evolutionary theory that's been applied to all areas of science, and yet he himself has doubt on whether any of it was true. And then we're locked ourselves into so much of this evolutionary theory, and it just seems ludicrous that we would be doing that. But of course, the secular world doesn't want to let go of these theories, which they would say is not even a theory anymore. They would say it's fact, but it's no more a fact than anything else. But any case, that's where we are at this time. And I'm not sure if you've ever heard of this machine. It's actually the biggest machine that's ever been built, called the Large Hadron Collider, and it's in CERN, Switzerland. And it's kind of underneath the ground there with these tunnels that they've made, this ground-breaking device. They're actually building a bigger one as we speak, but this one is 17 miles in circumference. And Basically, what they do is they get two beams of protons and they accelerate them with magnets in this 17-mile ring, and they get them actually close to the speed of light. And they get them one in one direction and another proton in another direction, and they smash them together at near light speed. And when that happens, it produces all these quantum particles that they can then measure, and they're basically the building blocks of the universe that they're able to understand. And back in 2012, there's a kind of a groundbreaking experiment that was done to try to find the Higgs boson particle. It's sometimes called the God particle. And it had been theorized for decades, but what this particle does, at least it's thought, to give mass to matter. And so it's very much at the very founding building blocks of the entire universe. And what they were hoping to, I'm not sure I understand all that goes on there, but it was found to have 125 giga electron volts of mass. But they were hoping that it would have a higher mass than that because it would prove that there, or at least give a good indication that there were multiverses out there. But unfortunately for truth, they found that it did not have the mass that was needed to prove these multiverses. And so they're back to the drawing board on that. But of course, they haven't stopped looking for it. They still hold on to this multiverse theory because that's really the only thing they have left. Our current universe, the more we learn about science, the more it looks like it's created. And especially when we get to biology, you can see that it's just astronomical results as probabilities of the way um, things have been tuned and designed. And so that's our only desperate hope is to find a multiverse that somehow they can say that, well, we just happen to be in the one universe that has life. Psalm 147, it says that he determines the number of the stars and calls them each by name. And that's kind of neat because, this wasn't like God just waved his hand and scattered a bunch of sand across the universe or something like that, like stars. Um, the very fact that he named each star shows how he feels about his creation. His creation is very special to him and he cares about it. It's been very carefully designed and not just haphazardly thrown about. Psalm 19, it says, talking about the sun, that it rises at one end of the heavens and makes its circuit to the other. Nothing is deprived of its warmth. That Hebrew word for circuit is revolution in this particular verse. And it says the exact description we use today for orbital motion. David wrote this around 1000 BC, and yet it's describing orbital motion and just very certainly hints, at the very least, of supernatural understanding. And in around the same time in 700 BC, the ancient Greeks believed the god Atlas held the world on his back. The Hindus believed that the world was held up by elephants standing on the back of a big turtle, and they believed that all the way up to the 1800s. So the secular world had very different viewpoints. They were trying to understand the universe just through their natural eyes. But the Hebrew Bible had it exactly right from thousands of years even before these so-called smart people of the world came about. Job 26 says he spreads out the north skies over empty space. He suspends the earth over nothing. Again, very accurate description of the way the earth is placed in orbit. Yet the Greeks thought the god Atlas was holding the earth up. So Job was written around 2000 BC, so 4,000 years ago. The scripture was absolutely correct and shows the earth's place thousands of years before these other cultures. Telescopes are very interesting devices. Of course, they've been around for a long time, ever since, optics were understood. And, even relatively recently, just a couple years ago, the James Webb Telescope came online, and it can see back into the universe further than anybody had ever before seen in the history of the world. And we're literally looking back in time because light does have a certain speed limit to it, and there seems to be, there's potentially evidence that it's can go different speeds, but at the very maximum that we've seen out in the universe, there's definitely a speed limit, and so we can look back all the way to very close to the Big Bang. And of course, in secular language, that would mean we're looking back, 13.5 billion light years. back into very close to the Big Bang. And just to give an example here, it takes light about 8 minutes and 20 seconds to get from the sun to the Earth. So the sun could explode and we wouldn't know it for 8 minutes. A lot of good that would do us, but there's the fact there. The North Star Polaris is 323 light years from Earth, so we see Polaris as it was 323 years ago. Sometimes, occasionally, there's exploding stars in the sky that people have seen, but depending on how far away it is, they may have happened hundreds or thousands of years ago, and we're just now seeing the results of that because it took that long for light to get to us. And this is a very interesting video by the Institute for Creation Research. It says, answers the question, did the universe begin with a Big Bang? That's a very common question. Let's see what they have to say.
How did the universe begin? Some people say that it came into existence billions of years ago in a massive explosion, but this Big Bang has some big problems. First, the antimatter problem. Whenever scientists convert energy into matter, they get equal amounts of matter and antimatter. Antimatter particles have the same mass but opposite charge. Supposedly, the Big Bang converted energy into equal amounts of matter and antimatter, but the universe shows no sign of this expected antimatter. Second is the horizon problem. The Big Bang model says that the universe started out very small and rapidly expanded. This would leave huge hot and cold spots since even a 13 billion year old universe is still too young for temperatures to level out. But the actual universe shows temperatures remarkably the same in all directions, no hot or cold spots. Mature galaxies pose a third problem. Light from the farthest galaxies we see supposedly took billions of years to get to Earth. So those distant galaxies should still appear undeveloped and chaotic, as they would have after the Big Bang. But distant galaxies look fully mature, not haphazard like the Big Bang predicted. Even the very distant regions of the universe reveal galaxies of magnificent beauty and complexity. In addition to these scientific problems, the Big Bang contradicts the Bible. The Big Bang needs billions of years, but God's Word describes the beginning of the universe happening in just 6 days only thousands of years ago. The Big Bang teaches that the sun and stars formed before the Earth, but the Bible says the opposite. Not by some problem-riddled explosion, but by the word of the Lord the heavens were made, and all the host of them by the breath of His mouth.
Yeah, that's a really neat video. We'll focus in on a couple things that they just said in that video here. They talked about this horizon problem. So this is where basically, if you have two galaxies, maybe one on 10 billion light years on one side of the Earth, um, another galaxy on the other side, and that's 10 billion light years away. Well, that's a total distance of 20 billion light years between those two galaxies. But the age of the universe, they say, is 13.8 billion years old. So that means that galaxy one, the light from it and heat and anything else that's being radiated from that galaxy could not have reached galaxy two yet. And so there should be hot and cold spots because of that. The heat from galaxy one has not reached galaxy two yet, and vice versa. So if the universe is really 13.8 billion years old, then the light and heat from galaxy one could not have reached galaxy two yet. Heat naturally flows from hot to cold. So again, you should see these hot and cold spots. Even secular scientists are contemplating that light was faster in the past. If that is true, and I think it is, then the universe is greatly younger than advertised. So again, there's this uniform temperature when you observe things out in the universe. Observe the temperature. There's no hot and cold spots like that should be there if evolutionary theory was true. Of course, the creation model accommodates an infinite or near infinite speed of light, which would fully explain the uniform temperature of the universe. And this is another interesting topic that they brought up about galaxies. If you look through a telescope, you're basically looking back in time at these distant galaxies. So you should be seeing a galaxy that was, 13 0.7 billion years old, as for example. So therefore, it'd only be a few hundred million years after the Big Bang, if that was really the case. And yet, you would think you would see, some very a chaotic looking cloud of dust and gas and things like that that's in the process of forming a galaxy, but you would not expect to see a fully formed mature galaxy. Yet that's exactly what you see. So it doesn't matter how far you look back in time, all you see is mature galaxies. And so the creation model accommodates these mature galaxies no matter how far back you look. Another interesting property about this horizon issue in the observable universe, which they think is 93 billion light years across and still expanding and even accelerating. But there's this concept of redshift and blue shift in as far as the light frequencies. And this is similar to the Doppler effect that you sometimes can hear about. And when you hear a moving train, for example, or something like that with sound, as a train comes towards you, it gets maybe a higher pitch, and then as it moves away from you, it's a lower pitch. Well, objects that are moving away from you are red shifted in their light frequency, and if they're moving towards you, they're blue shifted. Well, almost all distant galaxies are all redshifted. I mean, everywhere you look around the Earth, no matter which direction you look, things are redshifted. It's almost like, the Earth was the center of creation, the center of the universe, and then everything else is redshifted. There's occasional objects that are blue shifted, like the Andromeda Galaxy, but very, very few are, and most galaxies are all redshifted, as if the whole universe is expanding away from the Earth. And it should be noted there's no direct way to measure the distance of these faraway objects. Sometimes the shift in life, there's methods for determining distances based on this redshift, but these are error-prone calculations because it assumes a known speed of light between objects. And you see that a lot in various methods of calculating distances. One of the most commonly asked questions is, so why can we see stars that are millions of light years away if the Earth is only 6,000 years old? And so, the light travels about 6 trillion miles in 1 year, known as a light year. So if we can see galaxies that are alleged to be greater than 13 billion light years away, it would seem like the universe would have to be at least 13 billion years old, according to evolutionary theory. So again, how can this be if the universe is only 6,000 years old? Well, there's at least five possible solutions that I've come up with. Number one, God created a mature universe. Just as Adam was created a grown man and needed trees and plants with mature fruit to survive, God simply created a universe that was already mature. And that can be inferred from reading the Genesis 1 account of the creation event where God created plants and animals and not seeds and embryos. As you read through that Genesis 1 account, you can't assume that the physical laws that we currently experience were there at the very first of creation. There was certainly, the sun and moon and stars, there wasn't till the fourth day. So it may have been at least that point before the physical laws that we experience today actually came about. So we can't really assume that the speed of light was there on day one, the way we see speed of light now. It may have been an infinite speed of light, and I think it probably was. And we'll talk about that here in just a second. But just keep that in mind that the physical laws that we see was not maybe not the same throughout all days of creation. Well, there's certainly inaccurate distance calculations I referenced that a while ago. They have to be calculated. They can't be directly measured. One of these ways is to use a method called triangulation, use the concept of parallax. Typically, these can be, at least from what we know, fairly accurately measured up to 400 light years. Now, of course, 400 light years is a drop in the bucket compared to 13 billion light years. So it might be possible to do that. And this is kind of an interesting method because you can actually do it yourself. You can actually um, hold your a finger out from your head and look at your finger and reference it against the back wall or something like that, and open one eye and look where your finger is, and then close that eye and open the other and look where your finger is referenced on that back wall. and you can do some trig and you can actually calculate how far away your finger is from your eyes. This is called parallax. And we do that in space, this concept astronomically, by instead of our eyes, we let the Earth be on one side of the sun from the object we're trying to observe, and then wait 6 months later till the Earth's on the other side of the sun, and then observe that same object. And so it appears differently across the background, star background field. And we can again do that same trigonometry and we can compute how far away that distance is. But the problem is that that angle that gets formed from that method becomes smaller and smaller the farther away that object is, and it becomes so small that even the smallest little uh, decimal change in that angle causes drastic differences in the distance that you measure. So it just becomes really untenable to be able to use that methodology. And again, there's no direct method known to measure distances beyond 400 light years. Greater distances are determined by making assumptions that may not be accurate. Light may not take a non-direct route as it travels through space. It's kind of difficult to illustrate, but basically there are two schools of thought on how light travels through space. There's the straight line path or Euclidean, which is what we're typically used to thinking about, and then there's this curved path, Riemannian. And this is actually that curved path has actually been observed in 27 different star systems that we found. And you could almost think about this. What if the Earth was at the center of a sphere, and the sphere was the outer part of the universe, and light traveled on this spherical this surface. And if that was the case, then it can make the case that this curved path is really not as far away as we think it is. It might be 100,000 light years to us, as an example, to a galaxy because of this curved path, but in reality, linear distance wise, it's only 15.7 light years. This is just a theory, but it's something that people study. And this is a fairly simple equation to convert from the straight line Euclidean to the Riemannian curved space. And you can see this little spreadsheet here, as the straight line distance increases, even all the way up to an infinite distance, it approaches this 15.7 actual light years. That's actually there. So interesting that it kind of coalesces down to 15.7 light years. So it shows that the universe could be much smaller than we really think it is. Again, this non-direct route, we've actually certainly observed this. Well, we've seen that gravity influences the speed of light and where it goes and how it bends light. Remember, the speed of light that we've commonly talked about is the speed of light in a vacuum. And we've learned that the space is certainly not a vacuum, that there's dark energy, dark matter. There's other mediums that are there that light has to travel through, especially long distances. And it's obvious that it does not travel in a straight line, which would definitely give you a false sense of how much distance is really there. And you can see that for yourself. If you take a stick and put it in water, and you'll see that the stick, if it's as long as the sun's up and you can see bright enough into the water, that the stick bends as it goes into the water. Well, it doesn't really bend in real life. It's just that the light is traveling to your eyes at a different rate because the light is slowing down traveling through water. So it definitely, the medium influences the path and the speed of light. And actually, the speed of light has been measured for many, many years. Actually, the first speed of light calculation was in 1675. And they used the moon of Jupiter called Io and looked at how it eclipsed, or Jupiter eclipsed Io, and they looked at how the timing of that when the Earth was on one side of the sun, and then 6 months later, they looked at it as it went on the other side of the sun, and Io was eclipsed again by Jupiter, and they measured those timings, and they came up with their first measurement was around 300,650 kilometers per second. and they've been measuring it ever since. And they've had different instruments and different types of methods and those kind of things. And you think, well, maybe it's just because, well, in 1675 they just didn't have the right tools and instruments, and it's just been getting better over the years and that kind of thing. But they've done statistics on the accuracy of these instruments versus the accuracy of what they're measuring, and they're pretty confident, 99.46% confident that c, or the speed of light, was above its present value. And currently now, we see around a 299,792 kilometer per second speed of light. So it appears that the speed of light has been slowing down just in the last few hundred years. So what was it thousands of years ago, especially when the Earth was created? Uh, that could definitely be something to be looked at, and it'd be interesting. It would cause an uproar in physics for all of a sudden speed of light not to be constant, but it would be very interesting to reevaluate the equations that they use with a variable speed of light. And again, they've done other experiments. Remember that typically the speed of light in a vacuum is what's been quoted, but they've at the Rowland Institute for Science in 1999, they passed light through extremely low temperature in a vacuum that resulted in light slowing down to only 38 miles an hour. So that was still even in a vacuum, but they just made it extremely low temperature wise, and it caused it to slow down that much. The University of Darmstadt in Germany, they stopped light for 1 minute by passing light through a cryogenically cooled crystal. Well, think about that. Space has a pretty low temperature in most places. So is light just slowing down and causing us to have a false sense of how far in distance things are because the light is gotten that much slower due to the low temperatures? I mean, we don't know for sure, but it's certainly indication by our lab experiments. And then Pavel Cherenkov won a Nobel Prize in 1958. He generated faster than light charged particles in a medium that was water surrounding nuclear reactors. So Einstein's theoretical limit to the speed of light only applies to a vacuum. And we know space is not empty, dark energy, dark matter, and of course temperature variations, that kind of thing. So it's almost a certainty that light is not constant as it travels through space. This is kind of a fun little equation, a fairly simple equation known as the time dilation equation. And the twin paradox, that's a fun experiment that a lot of times in uh, Physics 101 and freshman physics that they will do for modern physics. And it basically means that speed of light influences the time that we're relatively looking at. We talked about that a little bit last class, I believe. But this twin paradox scenario just shows like if you had two twins on Earth, both the same exact age, and one twin takes a rocket ship ride to Alpha Centauri, which is 4.3 light years away, and then immediately comes back home. Well, he's only 8.6 years older, but his twin brother is actually 61 years. So very different time frame. And that's a very unintuitive, but that's you can use this time dilation equation, and you can actually see that very concept. And of course, he traveled at 99% of the speed of light, so very close to the speed of light. And the closer you are, then the more time slows down. And interestingly enough, the real world twin paradox has occurred. The astronaut Scott Kelly, he commanded the International Space Station for 340 days, so he was up there almost a year. His mission ended in 2016, but he actually has a twin brother here on Earth, Mark Kelly, who I think is a U.S. Senator. He used to be, at least, if he's not anymore. But because of Scott's time aboard the ISS, Scott is approximately now 14 milliseconds younger than he was before the mission relative to his twin brother. So I'm not sure how much that gains him, but he is 14 milliseconds younger than he was before the mission compared to his brother. And as I mentioned earlier about the physical laws being set in place, may be different across the days of creation. And that first day of creation where God said, let there be light, or let there be this energy, the physical laws that we see today may not be in effect. Remember, he said, let there be light. Psalm 104 says he wraps himself in light as with a garment. He stretches out the heavens like a tent. So it's interesting that he just um, made that verbal command, and there it was. So it kind of insinuates, at least, that it was just instantaneous across the universe. And of course, we see Einstein's famous equation: E equals mc squared. E is energy, m is mass, c is speed of light. And of course, it's just a rudimentary uh, looking equation. Of course, there's a huge amount of research and understanding that goes into that Einstein spent years coming up with. Um, but if you took that equation just to a very simple mathematical operation of solving for c, speed of light, well, if you had infinite energy, you would have an infinite speed of light. So, maybe who do we know that has infinite energy? If God said, "Let there be light," let there be energy. His infinite energy produced an infinite speed of light across the universe. Of course, there's no experimental evidence of what I'm saying here, but at least that is a concept to be thought of. And then, of course, we've been talking about these objects that are very far away, galaxies, Big Bang and all that sort of thing that are billions of light years away. But even our own solar system, locally, very close by, to relatively speaking, defies evolution. It violates the principles of angular momentum. Angular momentum is just a measure of the tendency of an object to rotate. We can see, almost like someone holding a ball on the end of a string, and you're rotating that string, around in a circle above your head or something like that. That's angular momentum. Well, a similar concept called a nebular hypothesis, of course, is thought about by the Big Bang happening, and this cloud of rotating gas occurs and coalesces into some mass there, and then as it formed higher mass objects, it would spin out as planets or something along those lines. It might coalesce into a star and spin out other planets, Venus and Earth and Jupiter and all that sort of thing. That this rotating gas cloud would just spin these objects out. That's known as the nebular hypothesis. And that's a commonly thought of hypothesis in the secular world. But there's various problems. The composition of planets are nothing like our sun if we were spun out of the sun. The rotation of planets and moons are way too fast. And even the rotation direction of the moons do not follow principle of angular momentum. So as an example, our sun rotates every 25 days, but the Earth rotates every 24 hours. So the Earth rotates 25 times faster than the sun. So this would be like having a ball on the end of the string, and uh, and maybe you're rotating it at 10 miles an hour above your head, and then all of a sudden the ball lets go, and now it's 250 miles and going 250 miles an hour. That just doesn't make any sense. And that's what we see in the universe, and no one can explain this. Certainly not the current secular laws of physics. Also, the orbits. All planets orbit in the same direction. However, they do not all rotate in the same direction. No one can explain this. Earth rotates west to east. Venus is east to west, and then Uranus rotates north to south. So again, that ball on the string example, if you're rotating that ball above your head and then it lets go, what direction do you think it's going to go? It didn't make sense that it would go the opposite direction that you're rotating it in. And so again, angular momentum is violated. Various moons within the solar system even have retrograde orbits. We see, some of the moons of Jupiter uh, have this retrograde orbit where the planet rotates west to east, but then the moon orbits east to west. So that doesn't really make a whole lot of sense from the standpoint of a nebular hypothesis. And many other planets, almost all of them actually, defy evolutionary theory. Mercury has a magnetic field. In 2011, NASA's messenger spacecraft took detailed photographs, and it measured its magnetic field and found it had decayed by 4% since it was last measured in 1974, only 33 years later by Mariner 10. So you can imagine if the universe and our solar system was really billions of years old, its magnetic field should have decayed long ago. It just doesn't seem like it should still exist if it decayed that fast, 4% in only 33 years. Venus looks like it has a young surface. Scientists were mystified to find that the surface of the entire planet looked young. It is claimed that 90% of Venus's history has been wiped from the planet's surface from some unknown global event. Volcanoes, craters, mountains, the entire terrain all look the same age. So could it be just that Venus is young and there's no missing 90% of history? Mars' atmosphere has too much CO2. There's too much carbon 12 and no known mechanism to provide a source for these isotopes for billions of years. Jupiter's strong magnetic field and heat and Io's its moon's volcanism. Jupiter radiates twice as much heat as it receives from the sun. How could it maintain that kind of output of energy over billions of years? And his moon, Io, is the most volcanic object in the solar system. How can this small little moon still have so much energy? Jupiter's strong magnetic field and internal heat, as its volcanic moon Io, are contrary to long Earth ages. Saturn's rings are too shiny and too close together. There's growing awareness that Saturn's ring can't be so old. They should be charcoal colored at the very least, from all the dust and debris that would accumulate on these rings, which are basically composed of ice covered rocks and things like that. So they should have accumulated much dust and dirt on these rings, and they over billions of years, and you shouldn't even be able to see these bright rings that we see. They should have, and the little moons embedded among the rings should have been flung away. This is a very young dynamical system. Uranus has a magnetic field and no dynamo source. There's no internal heat in the planet that we've ever found. So there's no power source for this dynamo. And so there shouldn't even really be a magnetic field, and certainly not the magnitude that we observe. So it violates evolutionary time frames as we see. Again, Neptune has a magnetic field and strong internal heat, radiating more than twice the energy it receives from the sun. It's hard to imagine how such a process could last for billions of years. And then Pluto should have had far more craters and no atmosphere. And it's actually been shown that Pluto actually has a thin atmosphere. I'm kind of bummed that they decided to take Pluto out of our solar system, because I think it's very much a part of our solar system, because there's very much to be gained from it and understanding how the age of Pluto supports creationism. Because there is a thin atmosphere. It should have dissipated millions of years ago if it was really billions of years old. So a young creation would definitely explain this. Another thing is the lunar recession. This is known as the lunar crisis among secular scientists. And the fact is that the moon is drifting away from the Earth at a rate of 1.5 inches per year, and actually would have been even more in the past. And as we talked about earlier, the moon is approximately 239,000 miles as far as its orbit from the Earth. But if the moon is really 4.5 billion years old, according to evolutionary theory, there shouldn't be the moon. It would have crashed into the Earth, or at the very least, it would have self-destructed. The tidal forces from the Earth would have broken up the moon at only 1.4 billion years ago due to its close proximity to the Earth. So 6,000 years ago, the moon would have only been 800 feet closer. So evolutionary theory does not allow for the moon to even exist. Evolutionists give two reasons for how the moon exists. The moon was free floating in space and happened to be captured by Earth's gravity. And then number two, a massive collision with the Earth at its early forming stage caused the moon to break off and begin orbiting the Earth. But either scenario would produce a much more elliptical orbit than the currently nearly circular orbit of the moon, even if either scenario happened 1.4 billion years ago. So evolutionary theory is not supported. The Earth's spin rate. The Earth is slowing down at a rate of 2 milliseconds every century due to lunar and solar tidal forces. If the Earth were really 4.5 billion years old, the initial spin rate would have to be significantly higher than it is now. Could the Earth have been rotating faster in the past? That's an interesting process and analysis. Gravitational forces from the sun and moon are constantly pulling at the Earth, affecting a slowdown in the Earth's rotation. Therefore, if the Earth had to rotate faster in the past, but how fast would that have been? So you can calculate this centripetal acceleration, which is just showing the radius of the Earth times the angular velocity of the Earth squared will give you the acceleration that we would feel as someone standing on the Earth. And so gravity has to exactly counteract that centripetal acceleration, or we would either fly off the Earth or be squashed by gravity. Um, but if the Earth were really 4.6 billion years old, the Earth's rotation would have to have started at a formation to be 2 times faster. Then the amount of gravity we would feel today would be a factor of 4 times more. So 2 times faster, our rotation of the Earth would give us a 12-hour day. So 4.6 billion years ago, if we had a 12-hour day, there would be weather would be drastically changed, probably high winds, atmospheric turbulence, as well as heat loss. So it just doesn't make sense for there to be this great difference in Earth's rotation rate than our 12 or 24 current 24-hour day. Moon dust. This is actually a very interesting one. The Apollo 11, when they were preparing for the astronauts to go to the moon, they were very concerned for them. Well, once they got there, they thought that they could be just landing on a big miles deep dust patch, and they would just sink into the dust and suffocate. Because there is the fact that the process is that ultraviolet light from the sun reduces exposed rock to dust at the rate of 3 to 4 ten-thousandths of an inch per year. So evolutionary theory would say, well, if that's the case, and you got 4.5 billion years ago the moon was formed, then you ought to have 22 miles of dust. Of course, creation theory says, well, that same rate of dust accumulation at 6,000 years, where you'd see 2 inches of dust. But of course, what did they find when they landed there? About 2 to 3 inches of dust, just as the creation theory has stipulated. Comets are another problem for evolution. Comets orbit the sun and are eroded by the sun with each pass. The tail of a comet gets longer the closer a comet gets to the sun, and the tail always points away from the sun. We're used to thinking in aerodynamic terms where you have kind of like a flag behind a vehicle or something, so it's always pointing behind the vehicle, but the tail points always in the opposite direction of the sun because the sun's solar radiation are impinging on that comet and causing it to erode all its material away and causing this tail to occur. And so, if the universe or our solar system, that is, was really 4 to 5 billion years old, then you wouldn't have any more comets left. They would have all been eroded and just nothing left in our solar system. All the comets would have either fallen into the sun by this point, or all their material would have been eroded away. So there should be no more comets, yet there are. So all of these planetary characteristics are difficult to explain if the solar system's planets, moons, and comets formed billions of years ago. They should be old, cold, and dead, but instead they exhibit examples of youth and great energy. What could possibly keep these objects hot, fueled, magnetic, or volcanic after these billions of years? Removing assumptions of billions of years solves many of these solar system mysteries. Tremendous energy remains in the planets from their creation only thousands of years ago. There's also this concept that we're learning about as we are able to stare into the vast universe and find exoplanets as we have. One of these exoplanets, and there's actually a number of them that they found called hot Jupiters. And this concept is they're seeing how they're being torn apart by their host star. Their orbit is so close to their star that planetary material is being ripped across or ripped off the planets. known as a tidal disruption event, or TDE. And the similar process is actually happening to stars too that are formed too close to black holes. The stars' components and materials are just being sucked into the black hole. So how could this have happened? How could there be a formation of a planet or a formation of a star, and then the process that we're observing is showing their material being sucked off the object, and this being around for billions of years. Scientists don't know how that could have happened, and they just say that we're just lucky enough to observe this process. But that just doesn't seem right. There's just no way these planets could have formed, and then at the same time, their material being ripped away. Both these processes violate the known evolutionary timeframes for planetary and stellar development. Secular scientists acknowledge that some of these TDE, or tidal disruption events, can last no longer than a few 100,000 years. So why did God create these destructive events if creationism is true? But actually, there's very valuable insights that can be gained about the planetary and stellar compositions and black holes. God desires us to study His creation, so these particular events are giving us great opportunities to observe and see, basically like the layers of an onion that are being peeled off these planets and stars, and we're able to see all the components that are made up of these objects. So it's a very much a learning opportunity, and I believe that's why God has created them for us to observe. And this video is very interesting. This is by Richard Dawkins. Interview with Ben Stein was the narrator, and it's a very enlightening to see a scientist. He's a very well-known atheist, and this was a part of a movie called Expelled, No Intelligence Allowed. We've seen some clips of this movie before. If you ever have a chance to see the whole entire movie, I would definitely advise it. But let's just hear what Richard Dawkins has to say about uh, the possibility of life and how life got formed.
Professor Dawkins seemed so convinced that God doesn't exist that I wondered if he would be willing to put a number on it.
Well, it's hard to put a figure on it, but I mean, I put it on something like, 99% against or something.
Well, how do you know it's 99%?
I don't.
Say not 97.
No, I did. You asked me to put a figure on it, and I'm not comfortable putting a figure on it. I just think it's very unlikely.
What? But you couldn't put a number on it?
No, of course not.
So it could be 49%.
Well, it would be. I mean, I think it's unlikely, and it's quite far from 50%.
How do you know?
I don't know. I mean, I put an argument in the book.
Well, then who did create the heavens and the earth?
Why do you use the word who? You see, you immediately beg the question by using the word who.
Well, then how did it get created?
Well, by a very slow process.
Well, how did it start?
Nobody knows how it started. We know the kind of event that it must have been. We know the sort of event that must have happened for the origin of life.
And what was that?
It was the origin of the first self-replicating molecule.
Right, and how did that happen?
I told you we don't know.
So you have no idea how it started?
No, nor has anybody.
Nor has anyone else. What do you think is the possibility that intelligent design might turn out to be the answer to some issues in genetics or in evolution?
It could come about in the following way. It could be that at some earlier time, somewhere in the universe, a civilization evolved by probably some kind of Darwinian means to a very, very high level of technology and designed a form of life that they seeded onto perhaps this planet. Now, that is a possibility and an intriguing possibility. And I suppose it's possible that you might find evidence for that if you look at the details of biochemistry, molecular biology. You might find a signature of some sort of designer.
Wait a second. Richard Dawkins thought intelligent design might be a legitimate pursuit?
And that designer could well be a higher intelligence from elsewhere in the universe. Well, but that higher intelligence would itself have had to have come about by some explicable or ultimately explicable process. It couldn't have just jumped into existence spontaneously. That's the point.
So Professor Dawkins was not against intelligent design. just certain types of designers, such as God. So the Hebrew God, the God of the Old Testament, he doesn't exist in your view?
Certainly. I mean, that would be a very unpleasant prospect.
And the Holy Trinity of the
No,
New Testament,
nothing like that.
So did you just catch what Dawkins just said? He said the existence of the Hebrew God of the Bible will be a very unpleasant prospect. So that's kind of the mentality of maybe not every secular scientist, but at the core of why they want to hold on to evolution, it really kind of is because it makes man accountable to God for their sin. That's why it's a very unpleasant prospect. Um, it's interesting that he talks about looking at the molecular biology and maybe they would find some signature of the designer. Well, he's got that right. It's exactly true. The more we understand about DNA and the more we understand about how the whole concept of life and the information that's packed inside the DNA molecules, the more we see the signature of the creator, which is God himself. So we'll talk about that when we get to the biology side. So how was the universe created? Psalm 33:6, by the word of the Lord the heavens were made, and their starry host by the breath of his mouth. So just a quick review. God created the heavens with such design that he gives mankind no excuse for not believing he created it. Dozens of physical properties of the universe seem finely tuned for life, so much so that even some secular scientists have adopted the intelligent design theory, even Richard Dawkins, as we just saw. God has placed Earth in a location that allows us to observe much of the universe. He calls each star by name. He holds his universe very special to him. He very much wants us to understand him through our universe. And the universe and even our own solar system seems evidence of youth and design. Well, that concludes the cosmology section of this class, and I hope you enjoyed that. A lot of information there. Certainly some things that are hard to understand, and certainly no one really understands it, and we may never on this side of heaven. But there's certainly, you can't make the statement that the universe is 13 billion years old and just say that with a straight face like it's a fact, because there's so much evidence that shows that it is actually a young universe. And hopefully that point was made. Next week we'll talk about geology and Noah's flood and how all that came about and how the fossil record got there, and very very interesting there too. So hope you'll enjoy join us next week, and we'll see you then. Thank you.